Good evening. I want to thank everyone. We've got about 10 more people need to sign in here, but we're going to go ahead and get started. I want to thank everyone for signing in tonight for this class on electrical getting amped up. This is a class dealing with defects. We're going to be showing you videos. The video will show. Then you go ahead and ask your questions, but we'll be telling you what the defects are. As you go along, just unmute your mic and ask away. This will be recorded. If you need it later, you can download it off the internet at our site. I'm Bryck Harris Bryck. I don't see him yet, but I know he's coming. He'll be here. Again, this is one in a series. We do one free class every month. We'll have some other classes going on in tonight's class, so we appreciate you signing in. Okay, here we go. We're going to get started here. Side here a second. Okay. So we're speakers nationally, and Harris is a licensed electrician for about 100 years. I've only been an electrician. Oh, there's Harris. Wave your hand, Harris, so we know who you are. There you go. There you go. So Harris has been around for about 200 years. Now that I got him on here. Thank you, Harris. Can you speak?
How you doing?
Okay, Harris, can you speak?
Yes, I could speak.
Your mic's not on. It's not plugged in or on.
It's on.
So go up to your picture, click on your name next to it, and click on the mic for your.
He's on, Bryck. I can hear him.
Yeah. I
have your mouth moving, but we can't hear you. So even though you're on here, you're off at your site. So go back to the cogwheel, click on microphone, and click on the mic and make sure it's on.
Okay. It says I'm unmuted.
Nope, can't hear you.
Hey, hold on. Let me look at something.
Or turn it up or something.
The rest of the
I can see you and I can see
here back me up. I hear Harris fine. It must be you, Bryck.
Computer audio
on. Go ahead and get started here. Electrical hazards can be found throughout the home, but are not limited to exposed wiring. And you can read these. Now, if you have a page, you see something, click on the right side of your screen. It allows you to take a picture of the screen as a JPEG. Okay? So if there's a picture you see or something you want to ask a question about, you can just see it from there. Okay, here's our first picture. Do I need a GFCI for that? Yeah.
Well.
So Harris, you find out why your mic's not working, Harris?
You need more than a GFCI.
Close out, Harris, and sign back in because we cannot hear you.
Okay, hold on. Let me get out of here.
Okay, so in this case here, I got exposed wire below 8 feet from the basement down. There's no correct receptacle for this, and it's an unsafe condition. So tell us what you see, and you're all from different states, so we're not telling you how to write a report, but tell me what it actually is. So one of the problems associated with these is no one wants to say anything. Okay, all closets, the new rule is, and when I say new, it's been that way for 20 years, I can't have an exposed bulb in a closet. Okay, so here's a chain pull with an exposed bulb. I also have a doorbell transformer mounted to the ceiling. That cannot be in a closet either. So that's 120 power with that location. Okay, Harris, you're still no sound for you to speak.
Can you hear me now?
Nope, no sound.
Can anybody else hear me?
Hey, Bill, can you speak to me? Can you unclick your mic?
I can hear you. I can hear you.
Hi, Bryck. We can hear Harris.
Well, Bill's unclicked his. I can't hear him either.
I can hear you.
Oh, weird. But you guys can all hear me, right? Thumbs up?
Yep.
Yes.
Yeah, you guys can hear me. Huh.
Yeah.
That's weird. Well, I can't. Bill, are you speaking? Because I could hear you before, but now I can't hear you.
Hello? No, mine's not lighting up now. I don't know. Oh, there it is.
Okay.
Yeah, I can hear Harris fine.
Okay.
Can you hear me now, Bryck?
Okay.
Can you hear me, Bryck?
I don't think we can hear you.
So I should be able to hear all of you. I clicked on that.
Testing 1 2. Testing 1 2. Do you hear me, Harris?
I hear you well.
There, I hit recording. Okay, Harris. I'm not sure why none of you guys can hear each other, but you guys can hear me. And let me go to can't have a snake. Okay, the service drop is rubbing on the sewer pipe vent hazard. And you can see here it's making a rubbing mark. Can you guys see my mouse?
Yes.
Yes.
Yeah, Harris, for
We
some
can see
reason
your
I cannot
mouse.
hear you. I don't understand why.
You can't hear me.
What?
Everybody else can.
I have it set.
It was
so,
working earlier.
I can hear all you guys speak. Camera audio settings.
Let me turn off my video.
Okay.
Maybe that's what it is.
Go to meeting. I set it up.
Can you guys hear me now?
I hear you, Harris, but can you hear me, Harris?
Huh.
I can hear you. Yes.
Okay.
Sean, can you hear me?
Unmute all. Okay. Harris.
Yeah, can you hear me?
Huh.
I know my mic is working, Bryck, so
Testing 1, 2. Testing 1, 2. You not hear this, Bryck? No, you don't hear. We were having a conversation before you got here, Harris.
uh-oh.
Still can't hear you. Oh, weird. Okay, well, we're going to continue on, everybody. I'm not sure why I can't hear anybody, but we're recording and we're moving along here. This all worked before. So, okay, here's our first video. Let's see if this actually, you can hear the sound from it.
Holy cow. Okay.
Oh, well, that's probably another reason.
Anyway, so I've been there, done.
Okay, so if I can't hear that, you can't either. Okay.
I heard it. Did you hear it, Harris?
I heard it, yes.
Okay.
What happened was when he put the
Can't hear
test
sound.
when he put the
Can't hear
tester
any
on
sound. Well, that's even worse.
GFCI
Bizarre.
breaker,
When I hit record.
tripped.
Why did that GFCI trip when he tested it?
Well,
Well,
because
here's something that's never happened. If somebody has a clue, let me know.
more current
So
went
we
out
can't
of
hear
the circuit
sound.
breaker and returned. So as long as that was more than 6 milliamps,
That.
it would trip the GFCI section of that breaker.
Gotcha.
Okay. Let's go back up to this.
So if he had the test lead on the neutral and then touched
Your speakers aren't working for some reason.
outright, it wouldn't trip.
Okay, but can you guys hear the sound when I'm playing it?
Yes.
Yes.
We hear it.
Can you hear? Okay. Bill, can you hear me speaking?
I can. I can hear you
Yeah,
speaking.
put your thumb up because I can't tell if you're hearing. Okay. So if I play the sound on my screen, can you hear the sound? Can you hear the video playing?
Yes. Yes.
You all hear it.
Anyway.
We all hear it.
Done.
Okay, so it's my speakers that aren't working. Oh, okay. So you're hearing it, but I can't hear any of you. Well, this is even stranger. Okay. Well, this all worked earlier. That's why we spend the time doing it.
We were talking earlier, Bryck. What happened?
Well,
Maybe turning the recorder on did something.
okay. Okay.
Holy
Okay.
cow.
Now I can hear that. Harris, can you talk?
Yes, I'm talking.
Okay, there we go. It was another button. Okay,
Can you hear
everybody.
me
I've
now?
been there, done.
Yeah, I can hear you now, and so we're set to
Okay.
go. Just another button.
So-
Sorry, everybody.
What I was
Okay.
explaining to everybody is you putting your test leads on each breaker to see if there was power. And then when you got to the GFCI type breaker, it tripped.
That's also Bryck.
More power left the breaker than returned on the neutral wire. Had you put the neutral the other test lead on the neutral and then touched the hot leg, you wouldn't have tripped the breaker.
Okay, can you guys hear him then? Does that sound okay? Yeah, okay. Okay, I'm gonna go ahead and play the next one here. Okay, Harris, explain to us what we're looking at right now.
Well, you're looking at looks like a pool panel. And of course you have the main pump, booster pumps, spotlight, irrigation yard lights. And so it's a exterior panel, and it looks like it's a rain type panel because you can see the lip on the inside. And so it's just a sub panel.
Okay, the breaker to the left is a 2-pole 240 breaker.
Right, 240 volts, 15 amps.
Okay, and the one on the right, now these don't say common trip on them, so these are a little bit different than what we'd see newer ones.
Well, no, they are common trip, but they, in the earlier years, they didn't always mark common trip on the breaker itself.
Hi everybody. Today we're going to show you something. This is main pump. Here we're going to show you the pump. There it
We have a
is.
lot of echo now.
Okay, I'm going to turn this on. Normally it turns on by a, and I want you to listen. Here we go. Okay, so we heard that sound twice. That sound occurs when the motor tries to start. It's a capacitor run motor. So there you go. This is why you need a home inspection.
Okay, did the echo stop?
Echo on.
Okay, did the echo stop?
Now it stopped.
Okay, so Harris, I want you to tell us, what is that sound we're
Hi
hearing?
everybody. Today we're going to show you something. This is main pump. Here we're going to show you the pump. There it is. Okay, I'm going to turn this on. Normally it turns on by a, and I want you to listen. Here we go.
Okay, what is that sound, Harris?
Okay, that sound is a overload sound, and the breaker tripped.
Okay, but I don't see the handle moving. Why?
Well, not necessarily. Sometimes the breaker handle does not move. However, the breaker did trip because it has an internal common trip.
Ah, okay. This was a little strange.
Hi everybody. I'm going to go ahead and show you here. We found this outlet behind the wallpaper and we used our volt stick, which we like. So this is why you need a home inspection. Booyah!
Okay, so Harris, how does a volt stick work?
Well, volt sticks work on induction, magnetism. And so when you have power in a wire, it produces magnetism. It causes the volt stick to light up to say there's power there.
Okay. Okay, Harris, what is this device we're seeing?
That is a tester. And it's a more sophisticated tester than your little volt stick.
Yeah. So as inspectors, Harris, are we required to use a device to insert it inside the receptacles?
No, we're not. But it's nice to have it in case you want to spend extra money and have it in your arsenal.
Okay. So some of you may want to use something like this if you want to go to the next level. It's up to you. What's this thing called, Harris? Harris? Harris?
He's muted.
You muted yourself, Harris. There you go. You're back.
I did that because my telephone was ringing and I didn't want
Oh, you're that guy. I got you. Thanks, Harris.
to. Okay, so you're not supposed to insert any test instruments into a receptacle, but if you do have it and you want to use it, yes, you can use it. It's above and beyond.
Okay. So take a look at the screen, everybody. It says 123 volts, right, Harris?
That is correct.
Okay, so here we go.
Okay, I think we're recording. It says that we are. Okay, so everybody look, and you can see here it shows 123 volts. And I'm going to go ahead and push the GFI button. It puts a load and it trips it off. That's your instruction for today. Thanks. Bye.
Harris, I don't understand. When I pushed that button, why did it trip the GFCI off?
Well, because you had voltage going to the ground wire from the hot leg to the ground. That means that there was an imbalance and the GFCI on the circuit caused it to trip.
When I'm looking at that outlet there, I see that the right side is small and the left side is large. Why?
That is a polarized receptacle. The small side is the live side and the big side is the neutral side.
So all receptacles are wired the same way?
That is correct. They're polarized.
Our SOPs, are we required to check for the polarization of receptacles?
We're not supposed to, but it's a good idea to check it. Yes.
Okay. Is that something called reverse polarity? Is that what we're supposed to check?
That's what you would check. So if you found
Yes.
that the small slot had no power and the big slot did, you would have reverse polarity.
Okay, so that's actually something we are checking for.
Yes.
Okay. Okay. What type of breaker is this?
That is called a twin breaker. 2 circuit breakers fit into the slot of 1 full-size breaker. 2 half breakers fit in the slot of 1 full-size breaker.
Okay, is this 120 volts or 240?
It's 120 volts per 15 amp circuit breaker.
Okay. And does the bus panel have to be the correct type for this to be installed in it?
Yes, there's certain sections of the panel where you can plug in a twin breaker like that, and there are certain sections where it won't be accepted.
Oh, cool. Okay. And we'll play this here.
Good morning, everybody. I've got a tandem breaker here. It's called a 1515. You can see it's a Murray breaker. It's also designated 1550, which means it's 15 amp. Now, the handles on this breaker are marked 15, and they're also blue, indicating that's what it is. Now, I want you to listen and watch. That handle trips that far, and that one makes that loud noise and trips all the way off. This breaker has no power on the 15 amp left side when it's on. In fact, it won't reset. Here, watch. We'll reset it, but there's no power on the wire when it's hooked up. Where this one on the right, you can hear the sound. So internally, that breaker has tripped off and no longer will reset. This tandem breaker needed replacement.
Harris, as inspectors, is there any way we can find this out by just staring at it like we did now?
No, you can't. You have to actually operate the circuit breaker in order to find that out.
Okay. So I happened to touch it and it tripped off on the left side, everybody. There was no power on one circuit.
Are you flipping breakers on and off, Bryck?
No. No, this one's not in the panel. I'm not, during an inspection, unless it's vacant, I'm never flipping any breaker on and off, ever. You're inspectors, not electricians.
Now, let me add one more thing that you didn't know about. When that breaker on the left-hand side was halfway off, showing in the position, it had never been turned on. In order to start a breaker, you shut it off first, then turn it on.
Yeah, that is correct.
And there's a big echo, by the way.
Good morning, everybody.
Oh, there's a big echo?
I've got a tandem breaker here. It's called a 1550.
Okay. How
You
about
can see
now?
it's a
No
Murray
echo?
breaker. It's also designated 1550.
Still an echo.
Means it's 15 amp. Now, the handles on this breaker are marked 15, and they're all blue, indicating that's what it is. Now, I want
How
you to
about now?
listen and watch. That handle trips that far,
No echo?
and that one makes
No echo.
noise
Thank you.
and trips all the way off. This breaker has no power on the 15 amp left side when it's on. In fact, it won't reset. Here, watch.
Okay. Let's go to this one. Now, this is the one that you're going to run into all the time. This is a kitchen. It's a flipper's kitchen, and they've gone ahead and remodeled it. So let's watch the video and see what we got going here to figure out what the defect is. And Harris, you can speak while it's playing, or you can wait till the end and we'll replay it again. You ready?
Okay.
Okay, here we go.
Good morning. This is our test today in a kitchen of checking GFI breakers. Okay, now we're going to come over here and we're going to see the GFI on the wall, GFCI, ground fault circuit interrupter. And in every kitchen, generally there's 2 circuits, and most of the ones around the, okay, let's go ahead and trip that off by using our tester. So the lights went off on the ceiling and the microwave went off. That's incorrect. They shouldn't be on the same circuit. So when I have an island, all island receptacles are also required to be GFI protected. So at this point, we know that the microwave and the lights are attached to all the receptacles on the wall. This is incorrect. As an inspector, this is what you should be finding.
Okay, Harris, you want to speak to that?
Sure. You have a bunch of different problems there. Number one, you have the GFCI, which controls the lighting circuit. Lighting circuit has to be on a 15 amp breaker, and the receptacles on the counter are on a 20 amp circuit. So you have too many items on the same circuit, and it's overfused. Number one. Number two, microwave is supposed to be on its own separate circuit from the panel, not on with anything else. There's a circuit just for the microwave. You know, there's a big echo again.
There's an echo.
Again.
Huh, that's weird. I have my... Okay, do you hear an echo now?
No.
Okay.
Harris is echoing.
Huh?
What's that?
Harris is echoing.
Oh, you're echoing, Harris. That's because your speaker and your microphone are echoing through the same... I keep turning it down so low I can barely hear here. That I don't hear the echo. It's at your end.
I can't control anything. It's automatic on this.
Okay.
I mean, it's always worked. Never touched it.
Okay. I'm going to play this one more time based on what he's just said so you can listen to what's happening now. Here we go.
Good morning. This is our test today in a kitchen of checking GFI breakers. Okay, now we're going to come over here and we're going to see the GFI on the wall, GFCI, ground fault circuit interrupter. And in every kitchen, generally there's 2 circuits, and most of the ones around the, okay, let's go ahead and trip that off by using our tester. So the lights went off on the ceiling and the microwave went off. That's incorrect. They shouldn't be on the same circuit. So when I have an island, all island receptacles are also required to be GFI protected. So at this point, we know that the microwave and the lights are attached to all the receptacles on the wall. This is incorrect.
So Harris, do I have to have 2 general purpose receptacles in a kitchen?
Yes, that's a minimum requirement. 2 circuits on the kitchen countertop for receptacles only.
Okay, and those are going to be GFI protected?
They have to be GFCI protected, and then each individual appliance needs its own circuit. Dishwasher has its own circuit. Disposal has its own circuit. Microwave has its own circuit. These are individual circuits that are required by the codes.
Okay, so when you do this inspection, how would you write this up?
Well, it has to be rewired. And again, you have the receptacles on the countertop that are protected by a 20 amp circuit breaker, and the lights in the ceiling, which are only rated at 15 amps. So it's overfused for the ceiling, and the microwave is tapped on the same exact circuit as the receptacles, and that has to be on an individual circuit all by its lonesome. So it has to be rewired.
Harris, I love your long description, but I need to write a report that I can finish this year. So my question is, when you write this up, what are you writing? Are you writing everything you just said to us? Or are you writing a shorter statement?
Well, an electrician has to rewire the entire kitchen area.
You mean like fix it so it's working properly?
Yes.
Thank you. Okay, everybody. Harris is an electrician, and he likes to use the word rewire it and add more stuff. But does the kitchen need to be properly wired? Is that what you're telling me?
Yes, it does.
Thank you. And I need the correct circuits installed as required by whom?
A qualified electrician.
Right. But I need the correct circuits installed and the correct wiring installed per the manufacturer's requirements. In other words, the microwave, the dishwasher, the stove all require certain wiring. You don't even have to talk about the code, just the requirements of what's required to wire these up properly. Now, we talked about the island. Does the island need to be GFI protected?
Yes, it does. It's a
And
receptacle.
all the receptacles on the countertop.
Yes.
Thank you. Okay, now I want you to watch this video, take a look, and tell me what the problem is, and then Harris will talk to it. So right now I see a wall light. What is that called, Harris?
Wall sconce.
Wall sconce, okay. And I see a ceiling light. What do you call that?
Recessed can.
Recessed can, okay. And then I see this device on the wall here that looks like a smoke detector or a...
Well, it could be a thermostat. It could be a carbon monoxide detector.
Okay, one of those, carbon monoxide. So something low voltage or battery operated. Okay, here we go. Okay, everybody, take a look at this. This is a three-way switch. Oh, light on, light off, light on, light off. Tell me why this is occurring. And whoever gets it right, I'll send you a Cupid doll. Thank you. Bye. Okay. Oh, great one. Tell me what's wrong.
Your fixtures, your recessed can, your wall sconce are not properly wired to the three-way switches.
Well, we know that, but what's wrong?
Well, the bottom line is that the wall sconce, which has a switch on the bottom, and if that is the actual use for turning on the light and off, should have power there all the time, not switch controlled. And the ceiling light should be switch controlled. And if it's on a three-way switch, the switch is not properly wired.
There we go. So on a three-way switch, a traveler is wired up wrong to one of the fixtures. So that's why one goes on and one goes off.
Yes.
So in this case here, this is my inspection, and they said, we just turn the light off with the switch at the bottom, like Harris said. So when the light on the wall's on, they just flip it off and move along on their day. Is this repairable, Harris?
Yes, it is. It's got to be rewired.
Okay, but I mean, do I have to rip the wires out of the wall, or is it just a matter of switching the wires around on a three-way switch?
Reconnect all the wiring.
Yeah, okay. Okay, Harris, I am looking at two fuses. Why is one different than the other?
Okay, the fuse on the bottom is called a NON fuse, doesn't have a second element in it for a startup. The one on the top is called a rejection type fuse, and it can only go into a switch that accepts rejection type fuses. Now, this type of fuse is used for air conditioning. It has a rejection clip on it. That means that it's got a dual element in it.
Okay, now when you see air conditioning, this one says 200 amps, so you're telling me big air conditioners.
Well, either big air conditioners, but sometimes what happens is you have a surge on main services, and this will accept that surge without tripping the fuse, without blowing the fuse.
Got it. But this type of knife blade, are we as residential inspectors going to see a knife blade fuse like this on an AC unit?
Not on an AC unit. No, it's too big.
Okay, so we'll talk about that in the next couple of slides so that everybody can see it. So these fuses here, are we going to see these type?
That you will see, because those are the type that are used for air conditioning. And the one on the right is for the startup. It has an extra element in it, so it can take the startup of a compressor.
You mean where the arrow is?
Yes, where the arrow is.
Okay, so if it's the other type with where there's no arrow, it's the wrong fuse.
It's just a common fuse, and no, it won't take the overload on a startup of a compressor.
Yeah, everything he just said, he said, yes, it's the wrong fuse. Thank you, Harris. So, Harris, I noticed it says the word bus there, B-U-S-S. Is that the same as the bus on a panel?
No, bus is a name brand, and bus on a panel is a type of, termination.
Are they spelled differently?
Yes, one is BUS, and this brand is BUSS.
Okay, so the bus and the panels, like the bus, the yellow bus you ride to school, like little seats. So that's probably why they called it the bus of the panel. Bus here is someone's name, right?
Yep.
Okay, thank you. I'm glad they had a nice name. Okay, these are just pictures of what fuses look like tripped or blown or melted. Let's start at the bottom one, Harris, where it's all melted away.
Okay. It's dead.
Figure 4, it says.
Yeah, figure 4 was, it says short circuit and several sections of the fuse melts instantly. And that is your fuse protection.
Yeah.
That is the part that protects you.
When that occurs, do you hear it?
Oh, yes, you will hear it.
Okay, so we just want you to know it's not like it's silent. You hear it because it's gone immediately. Okay, so you're not going to run into much of these here, so we're going to move on. Harris, this is a graph showing different types of wire, and we're going to deal with 14, 12, 10, 8, 6, and 4. What is 1, 2, and 0 for?
Okay, well, number 2 typically is for a electrical service for 100 amp service. And if you get up to number 1 and 1 aught, it's for a larger service. So
Why do
we
they
don't
have
normally
multiple
run into
wires?
that.
Hey, Harris, why are there multiple wires when they get bigger like that?
Oh, because after you get to size 6, actually 8, it's too hard to bend the wire if it was a solid wire.
Oh, okay. So that's why single strand wire 8 and below is typically solid and everything above it is multi-stranded.
That's exactly why.
Oh, cool. Okay, so these numbers here, 14, 12, 10, how do they come up with these numbers?
That's called the American wire gauge, and that's number 14 is the size of the wire that'll carry 15 amps safely. Number 10, size of a wire that'll carry 30 amps safely.
Now, why can't I put, why don't I have a wire that says like, it looks like the next one would be 16 and 18. Why don't I have those inside of a house?
Well, typically you do have that, but it would be for low voltage. It would be for belt transformers, all low voltage stuff, 16 and 18 and 20.
Okay, so those can't be installed in the wall then if they carry power.
No, the insulation isn't made for that.
Okay. What kind of wire is this?
This is called knob and tube wiring.
Okay. Do you like knob and tube, Harris, since you installed most of it in the country?
No, not anymore. It kind of got old and dried out and is dangerous right now.
Okay. So, a lot of people are running around. So when you see this, what do you say? The house needs to have an electrician
Rewired.
look at to rewire it?
Yes.
Thank you. Okay. Some of the insurance companies won't accept it. And I don't know why everyone says, oh, it's fine. Don't worry about it. Well, if you're in a car with tires that were 80 years old, you wouldn't drive the car, but so. Okay, Harris, what's wrong with this burned out receptacle on the wall?
Well, a couple of things. It was a short circuit there, and obviously it arced and it burnt the wall, and it probably melted the wires inside the box.
Okay, so when you're writing this up as for a report, what are you saying? What needs to be done?
An electrician needs to inspect and repair or replace the wiring in that box
And check for hidden damage?
and check for any hidden damage.
Okay, there's the secret, everybody. I see it, but they need to check for hidden damage, wiring that's melted past the receptacle box. Now, on the right is a switch, and I see single strand aluminum. When I see that, would you write that up, Harris?
Well, yeah, because it has to be single strand aluminum. The problem is if you look at the terminal, it's getting discolored. And that means there's a lot of resistance there, so that can cause a fire.
Okay, so is it easy to see this, or when you see aluminum single strand, you just stop and say the house is wired with single strand, repairs are going to be needed?
Well, in my case, I'll take the cover off and see how the wire is hooked up to the receptacle or the switch and make recommendations from there.
Okay, but if it's single strand, what should they say?
Well, that the house has aluminum wiring and it should be checked out by a licensed contractor.
Okay, so not further review, it actually needs to be inspected for safety.
Yes.
Thank you. Yeah, further
Right.
review, a lot of people are relying on that wording. Further review doesn't mean they're checking it for safety, everybody. So when you have something unsafe, the further review thing is something pretty important. Okay, Harris, I'm looking
I
at
got
this
a question,
panel
Bryck.
here. What?
I got a question. Should there be that antioxidant on those wires on that switch?
Well, when it's single strand like this, it doesn't matter what you got unless you're doing the, you want to talk about that, Harris? What the proper repair would be for single strand aluminum?
Sure. If you're going to hook it up to a receptacle or a switch, it has to be pigtailed. And the pigtail would contain a connector that does contain no lux or antioxidant. And then the copper wire would hook up to the switch or the receptacle. The big problem is receptacles and switches are not compatible with aluminum wire, only with copper.
Okay, so his question was, should you put gray paste on there? Should you put no locks on there or anything like that, or should you just write it up and have an electrician verify its safety and replace if needed?
You definitely have to write it up because, again, like I just told you, receptacles and switches are not compatible with aluminum wiring. So just because you put antioxidant on, all it does is prevent it from oxidizing.
Yeah, Harris, don't get mad at me, but when you say the word non-compatible, all I'm hearing is a word salad of blah blah blah. What are you telling me?
Switches and receptacles do not work well with aluminum wires.
Thank you. And so repairs are needed.
Yes.
Okay, so your client may not understand a word you're saying, everybody, and you say, oh, everybody understands the word compatible. Well, if you held them down and said, I want to know what the word compatible means, they'd probably give you 3 or 4 different answers. They're not going to tell you, I don't know what you mean. Okay, double tap wires, are those okay, Harris?
Not at all.
Okay.
Sometimes the type of breaker is acceptable for double taps, but this is not.
Okay, it says 60 amps over here. Is there any place in the world that a single pole 60 amp breaker would ever be used?
No.
Okay,
And those,
so what's
and
missing
those
between
wires
the
there
60?
don't look big enough to handle 60 amps also.
Okay, so the handle between the two is missing.
Yes.
Okay, so you'd write that up, and then I see doubled up wires, and the wires don't look big enough to be on a 60.
Right.
Okay, so the wiring's too small, and the breaker is missing the common tie trip between them.
Yes.
Okay, so I have 100 below. I see a big fat wire, and then I see the breaker on the top is off. So in your report, if there's a breaker off, you need to write it up and say the breaker's off. Now, before you remove the dead front cover, you should have looked at it to make sure all the breakers were on or off. There's nothing worse than pulling the panel, flipping a breaker off by accident, and then putting the dead front back on. Now, I don't know if all of you remove the dead front. Do you remove the dead front every time you do an inspection, Harris?
Yes, I do.
Okay, some states may not allow that. We don't know that. It's regional, but we pull the dead front cover. We're looking at all the wiring here. It's multi-stranded electric, and you're looking for heat defects. Harris, I see a cloth-covered wire, and I see here it looks like it's aluminum, but it looks like it's copper. What is it?
Right. That is tin-covered copper wire, and it's copper wire with the tin coating on it to prevent any oxidation.
Huh. So I see all these reports where someone writes up it's aluminum and it's cloth covered. Can we have aluminum cloth covered wire?
No, you can't. It would be copper wire, and cloth covered shows that it's very old wire, rubber covered wire
Okay, so
insulation.
look up here at the top, everybody. It's cloth covered braided wire covering, and if it's that, it's not aluminum. Okay, now I had somebody bring a piece of wire to me from Ohio, say, see, this is aluminum, and I went, ugh, whatever. but it was 1969. So this is always going to be copper clad with what?
With tin covering, tin coating.
Tin, tin. Okay. What kind of breaker panel is this?
This is a Zinsco panel, and those are Zinsco breakers. That has aluminum bus bar. Everything in it is aluminum, and they are now rejected.
Okay, so even the wiring on this was aluminum. Now I see somebody spray painted the whole panel. Is that okay?
No, once you get paint inside a panel, it's a contaminated panel, needs to be replaced.
Okay, so this is the trifecta of panels. It's a Zinsco breaker, it's aluminum wire, and there's paint inside the panel. So all those things are bad. Harris,
Yes,
are they all bad then?
all bad.
All bad. Okay, so we'll move on. Why did this cover short out, this metal thing on top of that receptacle?
Well, it looks like there was a little bit of a short circuit there. Somehow the wiring got touching the cover, and the aluminum or the metal cover completed the circuit and shorted out.
So the person that was plugging something in, did they hear this sound go off?
Oh, they heard the sound and they felt the heat blast and the spark.
So we just have to look for somebody who probably peed in their pants then, right?
Right.
Okay.
Yes.
Yeah. So is this a 20 amp receptacle?
Yes, that is a 20 amp rated receptacle. You can tell by the T slot.
So if you can't see it, push your face towards the screen and look, and you can see the T slot to the side. So T for 20. So can I have 20 amp wire on that?
Yes, you can have 20 amp wire, and
Okay, and what size?
typically you're allowed to have 20 amp receptacles on a 15 amp circuit because
Okay.
you're overprotecting.
Okay. Now at the top, it looks like little Mickey Mouse ears. What is that called on the bottom and the top of the receptacle?
That's called a yoke, and the yoke secures the receptacle to the wall and gives it a good solid stance.
Okay, so this is like the yolk, like a double yolk on an egg.
Right, except this is metal. You don't need
Metal
it.
yolk. Oh, cool. Okay, now I'm looking at a panel here. The top breaker, it says main on it. It has a screw in it. Why?
Well, when you're backfeeding a circuit breaker panel and you're using a backfeed, you have to have a screw securing that particular breaker into the panel so it can't be easily removed and it can't fall out.
Okay, so it's a backfed panel. Is that what we call it?
That's exactly what it's called, backfed.
Okay, so on a backfed panel, can I have tandem breakers in these?
Well, you'd have to look at the schedule on the side on the door to see if you could have tandem breakers. Most likely you can, but you'd have to check the panel schedule.
Okay, if I go down this panel, I see the main, I see two red ones here, and what size would those red ones be?
Those are 20 amp breakers.
Okay, then the next one down here says 30. If I look at that, a single pole 30. Why would I have a single pole 30?
Well, sometimes you can have a piece of equipment in your house that does require more than 20 amps, and yes, a 30 amp breaker, as long as the wiring is proper, you can have a single 30 amp.
Okay, what would that possibly be hooked to? That's 120 volts.
Well, it could be a heating element. It could be a 120 volt heating element.
Okay, so like maybe a compressor or something that requires a 30 amp circuit.
Compressor, a kiln or a compressor.
Sure, 120 volts. Okay. What's wrong with this wire to the right?
Well, it looks like you have an overheated wire. It started burning up and it discolored the lug that it's in, and it melted the plastic that is securing it and insulating it.
So
the panel has to be replaced.
So this panel, when I have this kind of damage with the main wires coming in, there's no way to fix this panel. It will need complete replacement.
That is correct. Has to be replaced.
Okay, so when I have a bus bar and the lugs are heat damaged, it will need complete replacement for safety.
Correct.
Okay, so everybody take a look at that. And if you want to snap a picture, you can, and you can use it on your website. So I'm not sure where on yours. on the right side, you can go ahead and click on it and do a JPEG picture of that. It's pretty profound. Okay, here we go. There's a lizard or a bug or something squished in there and it's been burned up. Harris, would the breaker be damaged possibly where this animal got fried?
It's possible, but unlikely because they don't draw a lot of power.
Okay, but would you write up in your report that the breaker needs to be removed to verify there's no damage to the breaker?
Yes, you'd have an
Okay.
electrician look at it to make sure there's no further damage.
Right, yeah. We'll be doing a class where I have a box full of breakers that were just like this, and once they get pulled out, they're all fried where they've been heat damaged. Oh, I'm sorry. Here's one of them right here. Okay, so this is what those breakers look like. So let's go back. There's the lizard, and here's what they look like when they're sitting on the bus bar. Okay, the one to the right is a 2-pole breaker, and the one to the left is a single pole breaker. And why does it have that burn mark there, Harris?
Well, that's because they had a loose connection, and the arc caused it to melt and damage the bus bar and the breaker.
And when that occurs, what happens?
You need to replace the panel as well as all the breakers in the panel.
So could they have fixed this earlier by replacing the breaker sooner?
No.
Okay, it just happens. Now, in a case like this, everybody, Harris, will you typically hear a buzzing noise in the panel?
Yes, a lot of times you would hear a buzzing noise or you'd smell something burning.
Yeah, so it'll be buzzing or humming or smells like it's burning when you're looking at the panel, so you don't have to know that much. You just say, wow, it's making this buzzing noise. This needs to be checked. And I've had electricians go, I didn't find anything. And I said, well, it's the third breaker down. You can, and if you have a heat gun or one of those little things you point at it, you can and say, wow, that's hotter. And some of you have infrared. I suppose you could use that, but I don't use any of that. I just, how do you determine that it's hot, Harris?
You can't just touch it because the normal operating temperature of a circuit breaker is 186 degrees. So can't go by that. You have to visually look at it.
Okay. So this meter here, this electric meter, let's see, it says 60 hertz here, 60 hertz. What does that mean?
Okay, 60 hertz means 60 cycles per second.
Per second?
And the cycle, alternating current per second, yes.
Oh, wow. That's pretty fast.
Yes, it is. That's why you don't see the lights blink.
Okay, so if I go ahead and I take a look right here it says 120 volts. Does that mean this meter is only rated for 120 instead of 240?
Yes, this meter is rated for only 120 volts.
Would that be adequate by today's?
No, the minimum today would be 100 amps, 240 volts.
Okay, so does everybody understand? This meter is only rated for 120 volts. That's all this house has. So if you're doing an inspection, this house is underwired by today's standards. Okay. Okay, now this one's a little bit different. It says it's CL 200, 240 volts, 60 hertz. And this is an older type with all these dials on it. Why don't we use these dials anymore?
Well, because they're outdated and the new meters are now electronically controlled where that you don't need a meter reader to come take those looks. It's all done electronically now.
Got it. Okay. Now, this panel here seems a little strange to me. I see a lot of wires coming into it. What is this panel special?
Well, this is a panel that's bottom fed instead of top fed. That's a start. And you could see that there's a ground wire there going to the top bus and neutral. So I'm going to have to guess, since I don't know any better, that this is a main panel. And it's a main panel, meaning there's no main circuit breaker, because if you look at the bottom, you see wires that are hooked up, and there's no circuit breaker to interrupt those wires. So this is a no main panel, And of course, we don't know what it's rated at because it looks like it has parallel feeders. And that's
So
not
here's,
allowed on panels.
yeah, so here, if I was looking at this, Harris, and I said to myself, okay, there's a meter outside with no disconnect or shut off, but in here I have this. I need to have how many disconnects minimum?
Maximum 6.
Okay, so 1, 2, 3, 4, 5, 6, 7. But this panel can hold many, many, many. So if there's no disconnect, this panel then's unsafe, would need to be replaced because it doesn't meet any of the safety requirements of today. Is that what you would say, Harris?
That is exactly right.
Okay. So here's a dead front cover. It's been removed and there's soot all over the back of it here. Soot. What's that usually mean, Harris?
That means that you had a short circuit and it arced inside the panel. And so the panel is most likely damaged and has to be replaced.
Okay, now where every filler plate was removed, there seems to be a little bit of rust where the air was being sucked in around the breaker and the rust oxidizes the location where the breaker is. Is that because the fire inside the panel was trying to get oxygen and rusted out the metal?
Yeah, that's what happened. Yeah.
Okay, so this dead front cover is the back side facing away from you. You remove it, and you always look at the back side before you go any farther, because if this is it, you probably need to step to the side. Here's another panel. It's got fingerprint marks on it. The whole inside of the dead front cover is all burned to a singe. Okay, everybody see that? So you got to be really, really super careful. Okay. Okay, so here's a main breaker panel, and in the panel is the main breaker here, and then I got all these other breakers running down. So if you look at the bottom, you can see here it's all black. See how the bus has burned everybody? And then look to the right-hand side, there's black soot all the way up the panel. Do we need to spend any time looking any further, Harris, or are we done with that inspection?
You're done with that. You just say the panel has to be replaced.
The panel is burned and is unsafe. It needs immediate. Is this an immediate one, or is this one they can think about it?
Well, it should be done immediately because obviously there's damage there and it's a fire hazard.
Okay, so it's unsafe.
Yes.
Thank you. Okay, here's the main service wires coming in, and these clips here, these compression things are all touching all these different wires up here. If they short out, what happens, Harris? This is your main service.
Well, you're going to have a pretty big explosion and cause a fire.
Okay, so they're all touching each other, and this is pretty bad, so it's unsafe. Here it is. Here you go. There's another one. So this is near a gutter. It's near a gutter, and there's only 2 wires going down this masthead here. So what's that tell you? What kind of power do I have at the SE cable?
It's 120 volts.
Okay, so the 120. So bad. Here I have 2 wires and a neutral. What kind of power do I have coming in there?
240 volts.
240. And then if you take a look, that wire just comes over here, and these 3 single wires go into the attic and run through the attic. Is that okay, Harris?
Well, it's okay if it's that type of cable. If it's SE cable, yes, it's permitted.
Okay, but if it's 3 separate cables running separately through the attic, is that okay?
That is not okay. It's illegal.
Okay, so they have to be wrapped together and called SE cable. What does that mean, SE?
SE stands for service entrance cable.
Thank you. Okay, so here's your full picture of your meter base with your goo here and your SE cable coming up and a drip loop here at the end and your connection to the eaves. Is that okay, Harris?
Yeah, that's okay because, you have the type of cable that goes down is acceptable back east, not out here. And that is an acceptable, main service coming in.
Oh, cool. Okay, here's some little baby wires hooked up and probably running over to a garage or something. These wires seem pretty teeny. So what would this be running?
Well, that's probably to a storage shed or something like that, maybe a light, and it's all not legal. It's got to be replaced.
So I have some wire nuts and tape wrapped around them. Is that ever approved for outside use?
Never approved. And
there you go.
Anytime you go overhead, you need a special type of cable.
Okay, so Afternoon, everybody. We're looking at a 200 amp panel here, and the breaker says 200. We're looking over here at the meter. It says CL 200. That's continuous load. It's underground. Our biggest issue here is when we look through here, this panel was designed for 40 poles. So if we count down through here, we have 45 or 46, if I was able to count. And they've installed the...
All
Hey, Harris,
echoes.
I'm mumbling here about poles. What am I talking about?
Well, I couldn't, it was all echoed, so I couldn't hear what you said.
Okay, well, I'm talking about there's 48 poles in this panel. So
Okay,
what's wrong?
most panels, the maximum is 42, including the main breaker.
Okay, so if 2 are at the top, and that's my 2, so I can't have more than 40 poles in this bottom half where my hand is.
That's correct.
Okay, so these are called twins.
Right, half breakers are twins.
And if we count those, it's like 48 or 9 of them. So something's wrong here. There's too many installed in the panel. So what do we have to
Not
do?
only that, those breakers, those twins on the top don't ever belong on the top because it's not, that panel doesn't have a provision for twin breakers up on the top part of the panel.
Right. So what do they do to fix this, Harris?
Got to replace the panel or put a sub panel in.
Okay, so they could just put a sub panel next to it.
Yes, pull some of the circuits out of that and put it into the sub panel.
Okay, so this was my inspection on a building over, I won't tell you where it is, but either way. So they pulled these breakers out and they said they got it inspected and it had been approved. Well, that was actually incorrect.
And the two top the two top units on the left side, those are called surge protectors. And that's the newest requirement on all brand new homes today, that a surge protector be installed on every panel, because all the equipment in these new homes are a lot of electronics and they need protection.
So this panel as wired, even though they said they got it approved and was installed by an electrician, was he a very good electrician?
Not very good at all.
Okay, so it's still wrong though, right?
It is wrong.
Okay, so all the things I said to you are true. They said they had it approved. They said they got a permit. None of that is true, and it needed to be corrected. So they had 2 electricians come out, and the first one said, I see no problem. Well, undoubtedly he knows nothing. The next one said, yep, we got a problem, so we'll put a sub panel in. They actually got a permit and got it approved to fix it.
Afternoon, everybody. We're looking
Okay.
at 100...
So here we go.
Hi, everybody. We're going to take a look up here. Here's our mast. We can see there's no protectors on the triplex coming in. Our support in the back is not in direct line. We'll take a look here. A lot of sun, sorry. And we can see that this wire is very, very tight. We're going to walk over here to our service today, and we can see we have a meter. It says 200 CL. We're going to back up here, and we're in Arizona, so everything's outside. Now, there is no defined main, so this is a split bus panel.
So Harris, on that panel, sorry, let me get back here. So on that panel, there's no defined main. So what does a split bus mean?
Okay, split bus means up on the top, there are 3 2-pole sections that you can put main equipment in, like air conditioning, water heater, range, anything that draws a lot of power on the top 6, including a sub main. And the sub means that the first 6 on the top, one of them controls the bottom part of the panel. So the bottom part is a sub panel, the top part is a main panel in the same one panel.
Okay, so in a case like this, if it is a split main, meaning I have my 6 or less, is that panel antiquated by today's standards?
Yes, it is, because too many homeowners were getting hurt because they figured they shut all the breakers off. They can now safely work on the panel, only to find that the panel is still alive. It's not off. Only the power
Okay,
company.
Yeah, so we just write that up. Okay, here's a picture of the bus we wanted you to see, and you can see the bus right here, and it's flat. There's no V-shaped mark in this. So, and I have this big gigantic breaker in here, and this has 200 amps right in the middle of the panel. So is that like a sub panel controller, or is that the main breaker in the middle of the panel?
Well, it could be the main breaker because they don't always have to be at the top or the bottom. They can be in the middle.
Right. So we don't know what it is based on this picture. So if you take a picture, you got to take it so we can tell us what it is, everybody. Okay. So the issue here is if I take a look at the bus, we can see the bus itself is not discolored, and I have all these breakers in here. And if I notice over here, there's no grounds hooked up at all here, or neutrals. There's nothing. I don't know where they're all at, but this is outside. We can tell that because here's the clip, here's the exterior door. There's an opening in the bottom with the knockout missing, and it looks like power is coming up from underneath here and running around. We just can't tell from this picture. There's a lot going on.
Morning, everybody. We're going to take a look at a panel here. First, I want to look at the model number. It's a 4040. That means full-size breakers. No tandems are allowed in this panel. Okay, we've taken off the dead front cover so we can look at it, and I want you to look real closely, and right there, I'm going to zoom in so you can see, there's our zoom, there's a tandem.
Okay, so in that panel, we're showing you the tandem breaker, and there's no rejection slot in the bus bar. What does that mean, Harris?
That means that breaker doesn't belong in the panel. It should be removed.
Okay, so that breaker right there in the middle doesn't belong in this panel. So right away, we have something wrong. And how do they get it to fit if it doesn't belong there?
You modify the circuit breaker.
So they take a screwdriver and break the rejection slot clip out.
Yes.
Okay. Okay, over here, I got two breakers with these metal clips on the side. What are those for, Harris?
Okay, those are locks to lock the breaker in an on position or in an off position. So you can
Okay,
lock
so
a circuit
lockouts.
breaker on, or you can lock a circuit breaker off.
Okay, so if I have those, I don't need to have a disconnect at the location of wherever that device might be.
That's correct. That gives you the safety of either locking it on or locking it off.
Okay.
Morning, everybody. We're going to take a look at this panel here. We're going to take a look here, and we can see multi-stranded wire. Some of the whiskers are not under the lug as required. Now we're going to come up here, and I'm going to look at this one wire. I want everyone to look at it and see. Do you see those notches cut in the multi-stranded wire? Guess what? Bad. Why is that bad? Well, once you cut a notch in the wire, the electricity travels in the outside of the wire. It's called the skin effect. So once I cut those wires, I have less wires, therefore more resistance. This is a problem and needs to be repaired immediately by a professional. Now look at this. That's notched. This one's notched. These are in 240 volt 2-pole breakers. Let's take a look up here, and our meter says 200 CL, 240 volts. For extra credit, somebody tell me what CL stands for. Good luck.
Harris, what's CL stand for?
Continuous load.
Uh-huh. Now, this panel is from a brand new house. They're not even living in it yet. And when I went to do the final walkthrough, this is what I found in the panel box. Would those wires notched the way they are need to be repaired, Harris?
Yes, they have to, because what's happening is, number one, the wires are brittle at this point, and any kind of movement can cause those strands to just break off, which reduces the capacity of the wire.
Okay, so bad.
And bad.
Well, we're using a screw gun because they use these 3-inch screws in here, and behind this plate we're in the garage. So I'd like to know why are we removing this? What's back there? It's a viewport for something. Yeah, there's a...
Well, those screws are about 3 inches long. He's using a screw gun to remove them. What's behind that plate in the garage, Harris?
Well, behind that plate would be a UFA ground connection.
Right, UFER. Okay. And
Every connection has to be available for inspection or remodeling or removal.
okay. So here's our tester again, everybody. And I love my little tester because it makes noise and it lights up. So Harris, if it's plugged into the right side, what do I have to touch to get that thing to light up?
Either a ground or a neutral.
Okay.
Hi, everyone. This is Brick by Brick Home Inspections. We're doing a little electrical testing today. Want to show you we're using our Fluke electrical tester. Here I've got my probe in the hot side, and I'm going to ground this out in the ground post. We've got good ground continuity here. Next test, I'm going to put it into the neutral side. Again, we've got proper grounding.
Neutral.
Neutral. Now I'm going to take this probe and I'm going to come over to our galvanized piping. Guess what? All metal piping in the house has been grounded or bonded. Good, that's good. Coming down here, the condition is the breaker was off to our dryer. And our dryer, we don't know what's going on, so we'll come down. We're going to come in for a test here. I've got 240 on this leg. I've got a continuity error on the second hot leg, which is incorrect. And if I come down to the neutral conductor, I've got power. So they have miswired this electrical box. Repairs needed.
Is this a normal test you do during an inspection?
Absolutely.
Not.
Yeah, it's a test you're never doing with your tools. So, Harris, was that outlet receptacle for the 240 wired incorrectly, or is he testing it wrong?
Well, he actually identified it wrong. That phase leg was on the same phase as the red test lead. And of course, you're going to read continuity rather than voltage because it's the same phase.
That's right. So, is it wired wrong, or is it because he didn't move his probe?
It's not wired wrong. It's because he didn't move his probe.
Okay, the breaker is off to the receptacle, but it still has power. That was the other issue. So it said
Right.
dryer off, and that receptacle was supposed to be off, but he was on the same leg. So this receptacle up here, where he's plugged in, and this side here are on the same leg in the panel, so you're not going to get any power between those two. Is that why, Harris?
That is exactly why. That's why it came up as continuity.
Thank you. Okay.
Now, if you said the breaker was off and you got continuity, the breaker was on.
Right. I know. Weird. Here we go.
We're here with Mike, the inspector right now, and he's got a 3-prong tester. He's going to plug that in. What's that one light telling us?
That tells us we have an
Unlike telling that it's correct wiring.
Devices that don't seem to work.
I'm sorry. What, Harris?
With one light on, it's correct wiring.
Okay.
This is Bert.
We're here with Mike, the inspector right now, and he's got a 3-prong tester. He's going to plug that in. What's that one light telling us?
That tells us we have an open neutral.
Plus, we plugged in some other devices that don't seem to work. Okay, now we're going to use our volt stick. And the volt stick tells us we have 120 power available, but no neutral. So the neutral is loose on this receptacle. And all of you are going to go, well, that's a piece of whatever device. It doesn't matter. It's just telling us that we need to go to the next level, have an electrician look at it. But anything you plug in will not work on this receptacle because there's no neutral. Okay, thanks everybody.
Okay, so this one here, Harris, was a little weird. It had 120 power, but there was no neutral, and we knew that because everything they plugged in would not work.
Right.
So
Mhm.
how would you know it's a loose neutral then if nothing works?
Well, you don't know. You have to have an electrician check it out.
Thank you. So the realtor had their computer plugged in and it went dead because the outlet wasn't charging. And then it turned out, sure enough, the neutral had pulled loose from the receptacle. Okay, everything in the kitchen worked except that one receptacle. Okay, now this one here, Harris, do you see the rust marks coming off the front of the dead front?
Yeah.
Tell me why.
Well, water has been getting in, number one. And so for some reason, it's not a watertight panel. And so it needs to be checked to see where water is getting into the panel and check to make sure that the bus bar is still intact and good.
Well, I thought the same thing, and that's what I said until I removed the cover. So if you look here, that's a straight line coming up off the top of the panel. Do you see how straight that is? See the streaks coming up straight? Oh, they're all leaning to the right there, straight up.
Mm-hmm.
Okay, let me play the video.
This is version 1 of inspecting panels. When you come up to a panel and you want to check it and remove the dead friend cover, we can see here that we have rust or oxidation on the front of the dead friend cover. We're not sure why at this point, but when we remove this cover, you'll figure out why on video number 2. It's a 200 amp service, and we can see here we have filler plates in multiple locations. We checked the panel for power, and we are going to open up the dead front cover. Take a look at version 2. Thank you.
Okay, we'll see if version 2 is here. Let's go to the next one. But this is oxidation from a high rapid fire where it was looking for oxygen.
This is version 1 of inspecting. Good morning, everybody. Now, one of the secrets of doing a home inspection is you take the dead front cover and you always check it first on the back side and see if there's any scorching. There is scorching, so take a look right here. Those are not my fingerprints, those are someone else's. So we removed the dead front cover, and that was the first thing we saw. Then as we come here, we take a look at the panel. As we come in here, we can see the bus is totally melted and damaged. The bus is melted here in the back. As we back away from it, the rest of it looks pretty darn good, considerably. But when we have a damaged bus like this, the panel will need to be replaced. There's no repairing this panel at all. This is an all-in-one panel. It's rated at 200 amps. It has a 2-pole breaker here with wires going down through conduit over to the garage where they have another panel. That's your 1 minute on inspecting panels. Thanks.
Harris, how would you write that up?
Panel has to be replaced.
Now, I wrote that up, and this was a pre-sale inspection, and 3 months later, he still hadn't replaced the panel, knowing it was that way, and the buyer had an inspection. They backed out of the deal because they said, what else are they hiding in the house? But, you know, it had been rented. No one complained that the lights weren't blinking or anything. But look at that panel. It's melted, everybody. It's gone.
Good morning.
Okay, here's that plate the guy was taking off with the screw gun, and then he flips this over and he looks inside there.
Okay, we remove the cover and we want to take a look in here, and here's a piece of rebar. And there's your clamp, your grounding clamp. So that piece of rebar goes into the foundation of the post-tension slab, and it's 20 feet of rebar, and that's number 4 rebar.
Okay, so that's called a UFR ground. Why the word UFR?
That was the person who invented that.
His last name was UFR?
Yes.
Cool. So if you had done it, it would be called what?
Bright ground.
A bright ground. I think that's much better. Come on. Okay, this is a disconnect. I thought disconnects had to have fuses in them.
Not necessarily. This one has what's called a pull out. If you look up there, right. It's actually has a switch. You can put that device in one way, connect all the wires, or the other way, it keeps it off.
Okay, so just so there's a way to disconnect it, doesn't it? But at the other end, like at the panel, I have to have the correct size fuses at the other end for this to work properly, right? To be wired up properly.
That is correct. Yes.
Good morning, everybody. Okay, here's their disconnect for the air conditioner. You can see right here there's no fuses or breakers, but that is within sight of my unit. As long as I have circuit protection back to the main panel, we'll take a look. It also says on the label 40. So we're going to go back and look and find a 40 amp breaker.
You're echoing,
Harris?
Yeah, it's correct, but you're echoing again. There's only one problem with that particular picture. The disconnect is behind the condensing unit, and it's got to be put to the side. 18 inches of clearance.
Yeah, you can't lean over the unit in front of you, everybody.
Hi, everybody. We're going to take a look up here. Here's our mass. We can see there's no protectors on the triplex coming in. Our support in the back is not in direct line. We'll take a look here. A lot of sun, sorry. And we can see that this wire is very, very tight. We're going to walk over here to our service today, and we can see we have a meter. It says 200 CL. We're going to back up here, and we're in Arizona, so everything's outside. Now, there is no defined main, so this is a split bus panel. And right here at the top is where the two wires connect, and they run up and they run down through the top. And then there's supposed to be no more than 6 disconnects in the panel, either at the top or the bottom. The problem we have here is we don't have that. So we can take a look here. 1, 2, 3, 4, 5. There's too many there, and there's too many at the top. So something's wrong. This will need to be repaired. Now, a couple other items we have here. We can look in here and see the neutral lug is missing. We're going to come over here. We got 2 wires. Here we have some other wires that have been on fire. A lot of heat damage on our neutrals. This panel's sort of a mess. We're going to need someone to correct this. Thanks a lot. That's your 2 minutes. It looks like somebody without skills wired it up.
Harris, what are you going to say about the panel?
Panel needs to be replaced.
Okay, so I have all that heat damage, and I got the wrong size breaker at the bottom. It looks like they just stuffed it in there and for some reason got it to stay without falling onto the floor. Okay, when you look at this panel, what do you say?
Looks like a nice panel.
Okay, is it backfed?
That is a backfed panel, yes.
Okay, so when you see the big wires coming in, that breaker must be secured to the panel. If you don't see a way where there's a clip or a screw, it's wrong. So power coming into the panel has to be in the lugs at the top or a breaker where it is and screwed to the panel. Why does it have to be secured to the panel, Harris?
It has to be secured because they are live wires that can't be shut off easily. So it's dangerous if it pops out by accident.
Okay.
This
We're at a sub panel located at a house. This is a backfed panel. It's a sub panel. We know that because they've isolated the neutrals and grounds off on a separate bar. They scratched the paint away in the background there. You can see it by taking off the paint to make sure we have a great connection. The only problem we have here is that we've got this bar running across the back. They've taken the lug and loosened it, but I still have a bar that attaches those two, so that bar must be disconnected and taken out of that lug. As we come down here, they've added a 40 amp breaker. This panel does allow you to have tandem breakers in it because I can see the rejection space there. This panel is rated for full breakers and also tandem breakers. It's rated at 125 amps. And you all say, well, how do I know that? Well, we're going to come over here. We're going to take a look right here, and it shows you, here's your tandem breaker location. And then the breaker panel itself is rated 125 amps. Thanks a lot, everybody. Oh, hey, it's backfed. So there's the screw that holds the breaker into the panel. And we have antioxidant on it also. Have a great day.
Is there anything else you would write up on that, Harris?
Well, no, but actually your second bar that's on the left-hand side of the panel does not have to be removed. It does not have to be disconnected. It is still the neutral bar.
Yeah.
You do have a separate ground bar, which is important. You need that.
Right.
The neutral bar can stay hooked up the way it is as long as it's not bonded.
Yeah, it's much easier to see it when you're just standing here, sitting in a chair going, oh, listen to that goof talking. Who is that? Okay, so these devices, the lights on them, sometimes it's 2, sometimes it's 1. Then there's a red one, you know, the amber. So you have to read what it says on it, whether it's right or wrong. We don't know it.
Okay, everybody, take a look. It's probably hard to see here, but the light, it's an LED actually, on the right side is blinking on and off. I want you to tell me why. This house has a non-grounded system, but it says this receptacle is grounded. I don't think it's bootleg, but we're gonna go check the service. They ran a new circuit here for the washer in the laundry area. So there you go. Go for it.
Okay, Harris. I want to know why the light on the right of my tester is low, dim, and why it's blinking.
Okay, well, number one, it's not LED. It's a, what do you call it? I just forgot the name. Neon. The neon light. Neon lights light with very little amount of voltage. Any kind of back voltage on that wire or induced voltage will cause that wire to light up, that light to light up and even blink. So it's just minute amount of voltages, but it's enough to light up the light.
Neon. I don't understand what a neon light is.
Well, neon is a type of bulb, and it operates at very low voltages. It doesn't take very
cool.
much. Yeah.
Cool. Okay, when I'm looking at that receptacle there, it looks like a little face on a pumpkin. How come?
Yeah, well, that's a 30 amp receptacle. It's rated at 30 amps. You could use it for a dryer. You could use it for a water heater. And that's each configuration goes to a different type of amperage and voltage.
I see. So, and you know that if you didn't know that, you could go up there. Would it have numbers on it? You could read them.
Right. If you look at the face of that, it'll say 240 volts, 30 amps.
I see. Cool.
Okay, everybody, we're going to be using one of these volt sticks. Some of you, your heads exploded when you heard me say that. But either way, I'm going to go ahead. We're going to stick this in the receptacle here. And this is a 240 receptacle. That's my hot side. Now, before we did all that, let's come on over here to a polarized receptacle. And our benchmark is we test it. Nothing here we shouldn't have. Nothing here we shouldn't. And we can see that it is functional. Okay, now let's come on back over here. And we can see we have power. Let's check here. Nothing. Nothing. Dead. And we're going to check our ground here. Nothing. So we have a problem with the 240 power coming into this. We're going to need an electrician to verify the reason why. This is the dryer receptacle. Thanks.
Okay, Harris, is that true?
That's true. If you have a problem, if you're not getting 240 volts, a 240 volt dryer will not work.
Okay. So and I keep calling it a volt stick. That's a brand name, everybody. What do you call that device that beeps, Harris?
Well, it's a voltage sensor.
Yeah. Okay. But before we had these, how did you test these receptacles? Just lick your finger and say, "Wow, that
Pretty
bit
much.
me" when you touch it?
No, actually, if we go back a lot of years, we used a bulb and a socket and plugged it in to see if the light would light.
Okay. Cool. Okay. So here we see the stick is green. There's a wire exposed running down the wall. Would this be a problem?
Okay,
That's a
everybody,
problem.
we're using our volt stick and we can see if this wire is hot. It's within reach. Of course, if you're tall, like my tall friend here, we're going to write that up. It needs to be protected from physical damage. Also, it's running across a gas line that's been capped off. Would you write this up?
Would you write it up, Harris?
Yes, it's not properly installed. It's subject to physical damage.
Okay. So how would they fix that?
Reroute the wire inside the wall.
Okay. Okay, we're outside and we're at the outside unit on a heat pump or an air conditioner, depending on how you're looking at it. And those two wires there, if I use this stick and went toward, would it show that there's power?
It would show power if the fan was on.
Okay, well, a lot of these, the fan doesn't even have to be running. You just have to have the unit energized. So let's see what happens.
Well, everybody, this is why when you have a splice for your motor, this is a aftermarket motor, and that beeping sound you hear is you getting shocked. What's happening here is that the connectors, quick connectors themselves, are leaking a little bit of current. That's okay, but if they touch the metal, they'll electrify the outside of the case, and then you get a shock.
Bad.
So this is bad. It needs to be fixed.
So you don't realize a lot of these motors, that those wires are hot. The leads are hot because it's activated because there's still power to the outside unit. So that's pretty unsafe, wouldn't it be, Harris?
Yeah, not only is it unsafe, the only reason the AC guys do that is because if the fan runs backwards, they don't have to take the whole unit apart to reverse the direction of the fan.
Right. Yeah. So the aftermarket motors can run either direction, and those motors only cost them like $40 instead of $300 for one by the manufacturer.
Well, hi, everybody.
Okay, Harris, when you first look at this panel, do you see anything that seems outwardly wrong?
Well, it looks like a couple of breakers on the left-hand side of the panel and not sitting in there properly.
Okay, so you see a space, everybody. I'm going to put my mouse there. There's a big space right here. There's another big space here. These breakers are not fitting in the panel properly. Now, are they the wrong brand, or they just didn't plug them in all the way?
Well, it could be both.
Okay, and then I can look down here and I can see all these ones with little doubled up handles, and they might belong in this panel or maybe not. We just don't know, huh?
Yeah, you'd have to check the panel schedule that's on the door.
Okay.
Yeah. Okay, everybody. Whatever we just said. Oh, we'll start over.
Yeah, I think I fell.
Here we go, everybody. We're at this panel. It's a 200 amp. We know that because it says 200. Why don't you take a look here and you can see this breaker's not seated in properly. Neither is this one or this one. We can look at the side and see they're not fitting in here. Here's some tandems. They're not fitting in regards to this panel. And we can see that the rest on this side seem to fit in. We'll come up here. It's a Murray panel. We'll take a look here at the brand and we'll look at the model number. 20 full size.
40 pole max.
And the 40 pole max is right here. Okay, so right now the breakers aren't seated in the panel. We got different brands. We'll take a look and have them, well, right now we need this fixed. Thanks a lot.
What's wrong, Harris?
Well, the problem is that you might have the wrong brand panel breaker to plug into this particular panel. On the panel schedule, tell you the approved type of breaker and the brands that are acceptable in this panel.
Yeah, it also said it was rated for 20 full-size breakers. That seems weird.
Yeah. Well, that means there's no room for twins.
All right, yeah, it says it'll hold 20 full-size breakers. And I'm counting them, and there's 9 in each side, unless we're squeezing another one in there somehow. So we've got a problem here, Houston, with this panel. So this will need to be corrected. Okay, Harris, when I have an RV plug, would that receptacle have 240 power, or would it be 120 power 30 amp circuit?
Well, some are 120, 30 amps, some are 240, 30 amps. You have to check the type of panel and the type of a unit that you have to see what gets plugged in.
Well, today's Volt Stick Day, everybody. I came up to this, I think it's an RFP plug-in. We're going to go ahead and check this. Now remember, our benchmark is we always have to test a cord or something we know works so we can test this. So we're going to come up here. Must be my neutral side. And then there's my hot side. Okay, so I'm going to come up here and I'm going to test this. Power. I'm going to test this side. No power. Maybe that's my neutral or not hooked up. And here's my neutral. So we're going to go ahead and we open this box up and we look inside there and I see one wire. So they've wired this up on one leg of probably a number 10 wire for 30 amps, and we run a separate circuit. So we know that the 120 receptacle is on its own circuit. Wow, I'm glad I had an inspection.
The guy wanted to know if he could use this for a welder. Can he?
He can use it for, needs to be screwed into the box.
Okay. Okay, this one was sort of weird. It takes a second here. I'm gonna run my mouse here, and you can see the triplex wires running across the roof, everybody. Here it is, running across the roof, and it's right next to hot water heater vent right next to this here, and it runs across the roof and makes a connection here. So it's touching the metal roof edge. It's touching the gas water heater, and the service pipes weather heads are only 1 inch. So what size services would those be, Harris?
Typically 60 amp maximum.
Yeah. So these services, because of the size of the service mast, would only be 60 amps. Okay, but they ran new triplex in, but it's laying right on the roof. Should that lay on the roof ever?
No, it should never lay on the roof. There has to be space at least 18 inches.
Yeah. So there was some guy up we're in Tucson, Arizona, and some guy up in Phoenix laid his ladder against the metal edge where there was a gutter, and he got electrocuted because the service wire was rubbing against the gutter.
Morning, everybody. We're taking a look here. We're at a duplex that's 2 units residential. We can see they have the compression fittings there. They're missing the safety covers. As the triplex comes along, it's laying on the roof. It's touching the flashing of where one of the water heater vents is missing. It's laying on the roof. There's a nail here along the perimeter. This is triplex going through the trees. This is an extreme hazard. Call the power company or electrician to repair.
Immediately.
Okay, is that unsafe, Harris?
It is very unsafe.
Yeah. So if it electrifies the metal on that flue, could it electrify all the piping in the house to ground?
Absolutely yes. And that's why you have what's called the bond wire in a house.
Yeah. So this building looks like it's built in the 60s or before, because it only has 60 amp services. So old. So unsafe.
Morning, everybody.
Okay, it's just another view of it. Same thing. Okay, here we're seeing a disconnect. The handle is down. Handle's down.
Well, here we are. We're an electric water heater. Here's our disconnect. The handle's down, but I have hot water. So when I look inside of this, I go, hey, here's a couple of fuses. They are 30s. It's 10 gauge wire. But I want you to take a look here at the handle. The handle moves up and down. The knife blades are disconnected from the connector here. This is a hazard. You don't really need this. This should be disconnected, but you can see down here the wires coming into the bottom are loose and there's a gap. But this is unsafe and needs repair. Now, if we come around here to the other side, I got the breaker panel right here, so it's within sight, so I have a disconnect. But this panel's unsafe. These type here normally would have a connector connecting these two knife blades together, so when I pulled it off, it'd be safer. I don't need further review on this one. This one I need a replacement or repair or a junction box, something. But hire somebody who knows what they're doing. Have a great day.
So Harris, if I had lifted that handle up and that metal bar hit the knife blades, would I be shocked?
You'd definitely be shocked, and it would cause a direct short if it hit both those blades. And
I would hear that, right?
Big explosion.
Yeah, I would hear it. Yeah, it'd be
You'd
one of those
see it.
videos you see online where everyone's going, holy whatever, you know?
Well, here we are. We're an electric water heater.
Why is the fan running so slow, Harris?
You're running slow for a couple of reasons. One, not the right voltage.
Right.
We'll take a look at this unit here. We can see the arrows go away from the compressor. It's a high pressure line. Here's our insulated line. It's not insulated all the way. The sun's deteriorated that. Here's our disconnect with the line of sight. Again, we can hear our pressure running. We can see this disconnect is loose from the wall here, and it's got a breaker. So we'll open this up, and the breaker says 60. It's a 2-pole, and then we'll come over here and we'll look at the label. And we'll take a look at the label here and see what it has to say, and then we'll go from there. Thanks a lot.
Okay, I couldn't read it because I was too busy thinking about something else. So were those fuses the correct size for for that, Harris?
I didn't read the label. It was too
Okay,
quick.
let's pretend we read it and we like it, but it says that it has R22 Freon. So that means this compressor has the old refrigerant in it, and if it fails, it can't be repaired anyway. Now, some of you say, oh, we get those repaired. Well, it's getting to the point now where no one wants to repair these. So this unit's on its last leg just based on age. Okay. Okay, here's again, we're testing this with our induction type tester. This wire is always hot, so this feed is unsafe. I want everyone to understand that.
Hi everybody. This is why this type of connection is unsafe. It's hot. So this connection should have been up underneath here, and this needs to be corrected. Bye. We're here with Mike, the inspector right now, and he's got a 3-prong tester. He's going to plug that in.
Does this seem familiar? Are you having a deja vu, everybody?
Plus we
Okay, so let me go back to this. So I put this one online about 3 or 4 months ago. It has about, I don't know, 10 or 15,000 hits. Everyone seemed to be in love with this one because they didn't understand. But the receptacle didn't work, and we used tools to figure it out, and it was a loose neutral, and they fixed it as soon as the electrician showed up. Okay, Harris, those disconnects way in the back here, it looks like they moved them based on the conduit, and they put them right here where we're standing. Why did they do that? From back there to here? Why?
Well, he did that because it's not easy to get to. You can see it's blocked. There are things in front of it. You got to have 36 inches of clear space to safely work on any kind of a disconnect switch or a panel.
Okay. Yeah, so the idea is not to be an Olympian hopping over ductwork to get to them. They have to be within reach.
Okay, everybody, we're taking a look at this unit here. There's 2 disconnects here on the side. You can see the boxes in the back. Why did they put these 2 new ones on the side? Well, it probably has something to do with being accessible. We're not in the circus, so the idea is I shouldn't have to hop over the ductwork to get to it. So inspector made them fix it, and there you go. Thanks. We're not pulling the fuses. The unit's running right now. That's the date of 2010. This is a heat pump. 2 disconnects because we have heat strips.
Okay, does anyone have any questions?
Rick, it's Steve. I do have a question.
Sure, go ahead.
On that one service panel that had the scorching on it and the dead front didn't appear to have the proper labeling of the circuits,
Yes.
you continued to remove that dead front, but on a normal home inspection, would you have stopped at that point and just written it up for a licensed electrician to further repair it or inspect it based on the unsafe condition and stop?
That
Pardon?
picture? You mean this picture?
Yes.
Yeah,
Yes,
well,
when
I
that-
didn't know it was that bad till I removed the cover.
But I mean, as a regular home inspector, I know I wouldn't have removed the dead front. I would have just marked it as it being unsafe or appearing to be unsafe, I guess.
Well, yes, that's where you do. You stop right there. I mean, Harris and I are, Harris, he lives life on the edge, La Vida Loco. He's just crazy. But the whole idea behind this is, unless you're wearing, shoes made out of some non-conductive material, you don't know what's going to happen. And this panel, it was totally unsafe. So I didn't realize what the rust meant at the time when I saw it, and neither did Harris when he was talking. But now that I've opened it, and so our protocol is, as soon as I remove the dead front cover, I look at the back of this cover immediately and I see what's happening, because it helps me decide whether I should step to the right or left instead of standing directly in front of the panel staring at it going, oh, what's wrong here? Harris, what do you do?
Yeah, well, you're right. You never stand directly in front of a panel. First of all, if you see marks like that, burn marks, don't ever remove the dead front cover. There's obviously a problem. You don't need to go any further to put yourself in jeopardy of any kind of injury. So don't remove the dead front when you see burn marks like that. Get an electrician to look at the panel to make sure it's safe.
Yeah, now these burn marks are not showing. They're on the side facing the breakers. So if this were on the outside and I could see it, I absolutely would not remove the cover. Now I've gone to these panels where the breaker is buzzing so loudly, bzzz, and you can hear it, and I just say, well, I'm not opening it. You're going to need an electrician over here because I'm quite sure what's happening. It's arcing inside the panel. So that's something that's going to have to be taken care of. Okay. Other questions? So that's what it looks like on the outside. That oxidation is the oxygen being sucked out of the panel. And when it did that, it arced and it caused this oxidation right up the panel on the sides. Look at that. Pretty awesome, huh? Cool. Okay, other questions? Wow, you're the best group. We don't know if you're sleeping because we don't have a camera on you. Let's see. So this type of tester here, a Wiggy was the standard one. I like this one because it's electronic. I keep this around because it allows me to test and put one probe in and touch something else to determine what it is. Before we cut holes in walls, sometimes if the client wants to know what kind of pipe it is, we can touch it and see if we have continuity. But I'm finding out some of the water, you get continuity with that. So Harris, if I took that device there and touched a stream of water coming out of the faucet, could I get continuity from that or power?
Not necessarily, because there are not enough minerals in the water to conduct electricity.
Cool. So if I do get continuity, what's that telling me?
That you have a lot of minerals and it's electrified.
Okay, so it could potentially conduct electricity. So one of the things you can do is you put your fingers on it and test it. But I'm going to shoot a video the next time I do this, because sometimes with well water, I'm getting a test on it. There's a lot of iron in the water, and it's showing continuity, which is sort of freaky. Okay, anything else, Harris? We're just about ready to wrap this up. We got 1 minute left, and want to thank everybody for signing in tonight.
I think we covered it pretty good.
Yeah. So defects. So if any of you are doing any inspections and can shoot a video, 30 seconds or less, that's uploadable, so you can upload it or you put it on your own site. Also, you can go look at our Facebook site. It's called Bryck Gabor, BRYCKGUIBOR. We have about 300 or 400 videos on there, which you can take a look at, and then we're putting more up every day. Harris, and then Harris and I, Two Electrical Guys. We also have a Facebook site for that called Two Electrical Guys.
Yep.
Okay, I think that's it. Anything else? Otherwise, have a great evening, everybody.
Thank
There
you.
we go. Thanks, everybody.
Thank you. See ya.
Thank you. Bye-bye.
Thank you.